energy density of electromagnetic wave. Energy per unit volume is called energy density. Denoted by U. So this energy density equal to energy upon volume. U equal to energy E equal to volume V. E the energy here, V the volume. The unit, this is now your joule per meter cube, joule per meter cube, and the dimensions m1 L minus 1 T minus 2, and it is a scalar quantity. In case of electromagnetic wave, we have the two vector fields, one the electric vector and second the magnetic vector. So there are two kinds of energy densities. First the electric energy density and second the magnetic energy density. In electromagnetic wave, electric energy density UE, this is equal to half epsilon naught into E square. Epsilon naught the electric permittivity of the free space, E the magnitude of the electric field. Where epsilon naught electric permittivity of free space and E the electric field. Intensity of electric field. So remember that this E and this E are different. This E the energy and this E the intensity of the electric field. Magnetic energy density UB is equal to half mu naught H square. H the magnetizing field, so this is equal to half V square upon mu naught. So here where mu naught equal to magnetic permeability of free space and B intensity of magnetic field. And here we have the relation this H equal to B upon mu naught. This is our relation. H is called the magnetizing field. And this value of mu naught half B square upon mu naught, this is equal to this half epsilon naught E square. So now we have this UB is equal to 1 by 2 now we have the relation that C equal to E upon B. So this B is equal to E upon C. So we can write that this is equal to E square upon C square into mu naught. See the speed of light. Speed of light and C equal to 1 upon square root of mu naught epsilon naught. So this UV is equal to half. If you put the value of this C square from here, then we can find that this UV equal to nothing but epsilon naught E square. So this is the magnetic energy density. So the total energy density of the electromagnetic wave total energy density of EM wave, this U is equal to UE plus UB. So now if we have this half epsilon naught E square plus half epsilon naught E square, so this is equal to epsilon naught E square, this is equal to U. So now you can see from here that the total energy density is epsilon naught E square. It means that these two energy densities, the electric energy density and magnetic energy density, are half of this total energy density. It means that the energy of the electromagnetic wave is divided equally between the electric field and the magnetic field. Now UE is equal to 1 by 2 into U. So this is the 50% of this one. So this UE is equal to 50% of U. Similarly, UB is equal to 1 by 2 into U. So we can have that this is equal to 50% of U. This is now UB. So now energy density, hence energy density of electromagnetic wave is equally divided between electric field and magnetic field. अगर हम इनका रेशियो निकालें तो क्या आएगा, दिस यू ई अपॉन यू बी, दिस इज इक्वल टू 1:1, or we can have that this UE is equal to UB. So now they have equal. So now these two energy densities are equal. So now we can have that if we take the ratio of this UE or UB with this U, then we can have this now 1 by 2. UE upon U. This is now 1:2, or this UE ratio U is equal to 1:2, right? So we can have this one, or we can also write it U ratio UE, this is equal to 2:1, like this. Similarly, this UB upon U is equal to 1:2, or this UB ratio U is equal to 1:2, or U ratio UB is equal to 2:1. So these are the answer to the questions which are asked in this from this topic, that what is the ratio of this UE and UB and UB to U, and what is the formula of this one, and you can have the just the idea from this one that the energy density is directly proportional to the intensity of the electric field. So the energy of the electromagnetic wave is equally divided between the electric field and the magnetic field. So this is about the energy density of the electromagnetic wave. So thank you very much.